So, I have been doing coding challenges all day, and I thought I might switch it up to something fun. But there's a riddle here. I haven't seen the solution yet, so I kind of want to see if I can maybe use some code to tackle this problem. And we'll watch together, and then I'll try to actually solve it using some code. So let's listen to what it is.
One of the top chefs from Pasta Palace has been kidnapped by operatives from Burger Bazaar, hoping to learn the location of their secret sauce recipe. Little do they know that a third party, Sausage Saloon, has sent you to take advantage of the situation. As their top spy, your skills range from infiltration and subterfuge to safe-cracking and reading faces for signs of deception. You've tracked the captors to where they're holding the chef prisoner. From your hiding spot, you can see him on the other side of the glass, while in front of you, an interrogator wearing headphones speaks into a microphone. We already know the recipe is on the 13th floor of the bank vault in a safe deposit box numbered between 13 and 1300. Now tell us, is the number less than 500? You can't hear the chef's answer, but you can see that he's lying. The interrogator, however, falls for it. He follows up by asking, is it a perfect square? Again, you can't hear the answer, but can tell the chef is lying, while the interrogator takes him at his word. He then asks, is it a perfect cube? This time, the chef answers truthfully. The interrogator thinks for a minute and says, good, now if you just tell me whether or not the number's second digit is a 1, we'll be done here. But as the chef starts to answer, the interrogator stands up, blocking your view. Within moments, he rushes out of the room, announcing that he's got the answer and is sending agents to retrieve the recipe. You know that the Burger Bazaar people have the wrong box number, but can you figure out the right one and retrieve the recipe yourself?
Okay, so interesting situation here. They have this is how they usually set it up. I'm sorry for the noise, by the way. There's this New York stuff going on outside. But effectively, you are given a bunch of a series of events that have happened to figure out what this number is effectively. And what is kind of cool is there are some ways that we can kind of already start working on restricting what possibilities there are. The idea, so the number is between 13 and 1300, so that's one thing. So I'm going to actually start busting out some code here. Let me do this. Is Ted Riddle. All right, Ted Riddle, and I'm going to move you over here. So there's some things that we're already restricting here. So I have, so I'm just going to write it out. So n is between 13 and 1300, and they say inclusive. They're all inclusive there. Okay. So you can tell whether or not. So you can tell if the chef is lying, and the interrogator, and this is I think an important point. The interrogator believes everything the chef is saying, basically. So you can you have to walk through what the interrogator is thinking, believing everything that the chef is saying. The chef lies about whether the number is less than 500. So less than 500 is a lie, or less than 500 response is a lie. Chef lies about whether the number is perfect square. So perfect square response is a lie. Perfect cube response is true. You don't know the answer to is a number second digit 1. Second digit is 1 is a question mark. Now, however, we can kind of work with some previous knowledge here about the perfect cube thing. So if the chef lies about it being a perfect cube. So I'm kind of thinking about from the interrogator's perspective. Perfect. So let's look at perfect cubes, right? So let's let me pull this up here. So if I have my perfect square, so I can do for let I equals 13 and I is less than or equal to 1300. And that should give you all of the perfect squares, right? So console.log perfect squares. And let's node challenge TED. Okay, so I have a bunch of perfect squares here. Perfect. Haha, it's perfect. So I have my perfect squares. Here, investigator, or the person investigating this, would not be able to determine. So if his answer for the perfect squares was yes, these are the only possibilities. If and then the investigator could ask, oh, okay, well, is the second digit a 1? There are only two. 216 and 512, which means that he will not be able to know the location with just this information. He would need more. So it would probably be including the other information that he's already gone with, which is whether the number is less than 500 and if it's a perfect square. So the question is 216 a perfect square or 512? I'm not entirely sure, actually. I mean, you can just find out, right? I'm going to call a function check perfect square. Wait, this is perfect cubed. Oh my goodness, I'm crazy. Cube. Okay, technically it's cubes here, and these are perfect squares. And actually, I don't need to do this anymore because I already know what this is. So that is fine. Check perfect square. So num. So these numbers are not, well, these are not perfect squares. Okay. So they're not perfect squares. Huh. Okay. So if they're not perfect, so neither one is perfect square. So you can't actually determine anything from that. I don't know. Actually, you can. Right? So if he says it is above 500 or it isn't above 500, then you would be able to tell. So I can only assume then, or I should assume, so it's possible, so he could have said above or below 500. He would have to say no to perfect square, but he's lying about that, and then said yes to it being a... Wait, what? Perfect square response is true. Oy. Man, riddles are definitely not my strong suit either, so... Nothing is my strong suit, basically. Very interesting. So if he says yes, the perfect cube, these are all the perfect cubes. Of those, oh, actually, there are some. Hold on a second. let me. So I'm gonna say perfect cubes equals that. Check for perfect square, and I'm going to say for. I can do another way, actually. I can just do that dot filter, and you literally just give that in there. Interesting. So of my perfect cubes, there are two that are perfect squares as well. So there are two lines of reasoning that I need to follow, and we can follow them now. I'm going to balloon this out here. Okay. So there are, so we have like above 500 and then below 500. I think there's like multiple ones of these, right? So if his response is, hey, it's above 500, they're thinking, okay, is it a perfect square? So perfect, so yes, perfect square. and versus no, not perfect square. And then this gets duplicated, and this is duplicated as well, and then you go to the perfect cube answer. Yes, perfect cube. This is no. This is no. Okay, so these are all the possibilities that the investigators are going to be able to have here. So if he says above 500, perfect cube, and perfect square, well, actually, so let's see. If you look at all the perfect squares. So we look at all the perfect squares, then this is all they are. Above 500, perfect squares, these are them, and there are none here. So anything he says would be irrelevant, and this doesn't count. This can't be possible. Not possible. Because there are no perfect squares that are also perfect cubes above 500. Oh, sorry, that is true. No. So there are. So it is possible. My mistake. Yes, it is possible. And once, if this was the case, then you would have your number. You would not need to ask a third one. So this is not what investigators see. So this is potentially our answer. Because if he says yes, a perfect cube, then, and all these other things happen, so he could have said no to this, which would have led them astray. And he could have lied about this and led them astray also. So if that's the case, then let's look at the opposite here and what they're thinking if this is the case. So if he said, so he lied about the first one. So he says below 500 and no to perfect square. So it's this one, and let me put it at the top here. So it's this one, and yeah, I think I messed something up here. So this is not. Same thing here. Sorry, this is this situation here. The opposite here, perfect cube, yes. So if that is the case, below 500, not a perfect square, would be here. Sorry, here. And that would justify the question for it being, so this justifies, actually no, does it really? I don't think so. Because these are all below 500. Because if this is if he says yes, it is a perfect cube, these are the only possibilities. And asking the question, is the second digit a 1, would not eliminate all the possibilities. So this is also it's not restrictive enough, basically. Above 500, not a perfect square, and not a perfect cube. Well, then that's too many possibilities, I think. Too many possibilities. Right, like that's not restrictive enough. Because there are going to be a ton that have 1 in the second position, so this is not good. Above 500, yes, a perfect square, but not a perfect cube. I also feel like those aren't going to be restrictive enough, right? Because if it's above 500, then that's... Ooh, you know what? I think I could code the... you know what? I'm being silly. I should be more modular about this. Functions in mind, right? So let's all the functionalities we need here. And to check this, I would need to get the perfect cubes with bounds. Bound being above 500, so 500 and 1300. And that will give you an array, and then you could do filter check for perfect squares. So let's see what that gives me. 279. Okay, 729, right. Perfect. Okay, so that works. As expected. Cool. And then I could just like go down the line, really. Above 500, yes. Not a perfect square. Not a perfect cube. So that's just too many possibilities. I'm not going to bother with it. Yes, a perfect square, not a perfect cube. So I'm going to get the perfect squares then. Perfect squares between that, and then filter for check perfect square. No, I don't need to check. but I do need to filter on if the number 1, second place. There are none. Okay, so we've already kind of deduced this is also not worth asking 1 in second place. Because there literally are none here. So this one's not working. This one looks good for our purposes. Above 500. Perfect cube. Okay, so perfect cube. Above 500. Okay. Perfect cube above 500. But it's not a perfect square. So that's filter. X, and this is true. Alright, let's see what this looks like. So we should have a bunch of numbers. Oh, not that many. Cubes that are not perfect squares. True. Aha! This is also interesting. So, and then it would be reasonable to ask this then. Because then you can say, filter again and say, okay, 1 is second place. And then they would see 512. Possible. 512. If it's a perfect square, yes, and a perfect cube. Perfect square and a perfect cube. So that'd be between 0 and, or I should say 13 and 500. And is a perfect square. $64. So this is also 64, but you see it doesn't have a 1 in it. So this is possible for investigators. The issue is, though, like, without this filter, what do they see? They see 2 possibilities. Oh, yes, very possible. Versus 512. So they only see two possibilities here. Which is why they would say, oh, once you tell us this answer, then we'll know what it is. So this is very likely the case there. Let's keep going. Below 500, not a perfect square and not a perfect cube. Again, it's too many, not restrictive enough. So this is not even worth talking about. Yes to perfect square and no to perfect cube. So this might work, but I think there's still like too many to like do. This is, so sort of the last thing is, yeah, there's just too darn many here. Too many. So same situation here, too many. So this means that this is the only possibility. So this is what investigators see. This is what they get. They get this. He says above 500, no, it's not a perfect square, and yes, it is a perfect cube. But what actually is the case is that it's below 500, it is a perfect square, and it is a perfect cube, which is 64. So 64 is the answer that we're getting. Period. I solved the thing. Woohoo! Okay. We're going to get 64 as the answer, and they thought it was 512. Logic. Took a while.
The key here is to work backwards. We don't know what the chef answers to the final question, or whether he answers truthfully. But we do know that by the time the interrogator asks it, he's narrowed the options down to 2 numbers. One where the second digit is 1, and one where it isn't.
512 and 1,000.
Our goal, then, is to find answers to the previous questions that lead to just 2 possibilities. Of the 3 constraints offered, the one that narrows our options the most is if the number is a perfect cube. That leaves us with only 8 answers between 13 and 1300. So let's assume the answer to the third question was a truthful yes. Now, let's look at the second question. If the chef answered yes to the number being a perfect square, It would narrow the interrogator's options to just 64 and 729, the only numbers in our range that are both a square and a cube. But neither of these has a 1 as the second digit, so the given answer to the second question must have been no.
No, right,
And
okay.
that also means
Okay,
we
what?
can eliminate these 2 squares from the interrogator's list, leaving only 6 numbers. Now for the first question, which allows us to divide this list. If the chef answered yes to the number being less than 500, we'd have 4 options, which is too many. But a no leaves us with 2 numbers greater than 500,
Right.
one of which does have a 1 as its second digit. We don't know which of these numbers the interrogator thinks is
Doesn't
correct,
matter.
but that doesn't matter.
Yeah.
Remember, his conclusion
It's
was
wrong.
based on lies.
Haha.
You, on the other hand, are now in a position to reconstruct the truth. First, the chef said the number was greater than 500,
It's
but
not.
lied, meaning it's actually less than 500. Second, the chef said it wasn't a perfect square,
But
but
it is.
lied again, meaning the number is indeed a square. And finally, he truthfully confirmed that it was also a cube. And as we've already seen, the only number under 500 that's
Oh!
both a square
Fucking
and a
freaking A,
cube
okay.
is 64.
Yeah, I don't know. Like the way they solved it, obviously, like they know the answer, so it sounds easy for them. But like the logic of like figuring it out and like creating all this stuff was definitely excessive. I think I certainly could have been more logical about it. So in hindsight, I think I could have put more pen to paper and just not done a bunch of like coding stuff. I could have just figured out the logic behind it. Anyway, that was interesting. I'm glad I got the right answer, and I hope that this was fun. And maybe you can try out another one of these. I'm gonna try. I think I'm gonna look at the next one and see what that looks like. Anyway, I'm off, and I will see you around. Bye.